OK. Yeah, I'll just reiterate who I am. My name is Tiffany. I work at SoundCloud in Berlin. Currently, I'm an engineering manager. And last year, my final project when I was working on the user auth team was leading a cross-team effort to build a keyboardless sign-in experience that we launched when we launched our Xbox app. I found it really interesting with a lot of juicy details, and I'm here to share those details with you. So the best way for me to explain what I mean by remote sign-in is saying that it's a method for signing in to a device that doesn't have a keyboard. And I'm going to show you exactly an example of this in a moment. Google calls this sign-in for TVs and devices. There's not really a standard name for this. Some people call it pairing. Some people call it activation. In any case, I've written a detailed blog post about this. You don't have to take notes. There's a lot of material, but it's all in my blog post, and I'm also going to share that on Twitter at the end. So yeah, a little overview of what I'm going to do. I'm going to talk about a case study, which is the SoundCloud on Xbox. Show of hands if you do not know what SoundCloud is. Cool. Moving on. It's really hard to see the people not raising their hands when I ask who does know. So, quick update. You want to? Someone needs to explain to that one person if they don't know what SoundCloud is. It's a music streaming app. Anyway. Yeah, I'm going to give a little case study. Then I'm going to explain how it works, sort of what is the API calls back and forth from the different devices, so you can sort of understand what the implementation is. Then we'll go over some UX considerations, and then we'll go over security considerations. I want to focus on how it works and the security considerations, so I might kind of blow through the UX considerations a bit faster than I would normally feel comfortable with. But that's cool, because it's all in the blog post. So, SoundCloud on Xbox. When we were developing SoundCloud on Xbox, which, by the way, looks awesome, and you can actually see it in the browser. If you Google around, you can find out how to get it in your browser. Something became very obvious during usability testing, and that is that signing in with a game controller is not fun. It's terrible. Here's a GIF showing someone entering. So there's an on-screen keyboard, and you've got to navigate to the characters. And the letters and the numbers and special characters are all spread across different screens. So the better your password is, the worse this feels. Also, they're like hiding the character. And I guess your friends can see what you're typing, but not, you can't. Anyway, it's terrible. So we realized we needed another way that was simple and fast and secure. And something especially fast, because we really wanted people to just start using the app and feel fun and have fun and listen to music and move on, right? So I'll show you the solution in brief. This is the what is the case study of how this works. So the person, they want to sign in to SoundCloud on Xbox One, and they see this screen and they navigate to the sign in button. Immediately after, they're told to go to this URL, soundcloud.com/activate, on another device, like their phone or their laptop. And then they're going to enter that code. They're shown this on a screen. So they dig between the sofa cushions, and they pull out their phone. They type in soundcloud.com/activate, or they pull out their laptop. And then they enter that code. That's it. They're signed in. Then we tell them how to use navigation controls, which is a whole other UX talk. So the main thing is, we really wanted to take advantage of the fact that they're already signed in on their phone, or they're already signed in on their laptop, and they just want to be signed in on their game console. So how does this work? Like, how does this functionally work, right? I'll give you an outline of how it works. Consider two devices, a game console or your fridge or a watch or something without a keyboard, and then another device, probably your phone. And the person wants to be signed in to your service on the game console, but they have their other device nearby. So the app on device A talks to your web service and says, hey, please give me a code. And the service is like, here you go, it's ABC123. That's the code that you should show to the person. And the device A then begins polling to check on the status of that code. So it says, hey, what's the status of ABC123? And your service is like, it's not activated. It's like, hey, what's the status? It's not activated. Hey, what's the not activated? And this keeps going. And in the meantime, the person pulls out their phone, and they go to this easy-to-type URL. Pick something easy. You don't want like / sign in on Xbox without a, something nice and easy to type. You could also show a QR code, and they navigate to it that way. And then on this device, they might already be signed in. If they're not signed in, they have to sign in first. And as soon as they are, they're shown this screen. And they're prompted to enter the easy-to-enter code. They do that. And then when they do that, that device's app says, hey, is this code anything? Is this a real code? And the server's like, yes, that is a real code. And at that point in time, the person then confirms that they want to continue for security reasons I'll go into. And they confirm that. And when they confirm that, they're sending the access token, the identifier of the person who signed in, along with the confirmation, and says, here's my access token. Please associate it with that access token. So now, this ABC123 is now associated with the user who confirmed it, which gives us a good time to go back to our game console. Our game console is polling. It says, hey, what is the status of ABC123? And your server says, hey, it's confirmed, actually. And the server's like, great. Could you just take this code and just tell me, like, give me an access token for that user now that it's ready? And the web server says, here's a new access token. And now, by definition, voila, if you have an access token, that means you're signed in. So the polling happens until it's ready, and then it gets the access token. So the inspiration for this was essentially YouTube on TVs, and something called Google Sign-In for TVs and devices. And our flow is very similar. It's very much influenced by this. And there's a link in my blog post, which is you can go to the Google documentation and you can read this in detail. And you can see exactly an example of an implementation. But also, if you don't have your own authentication service, you could use Google Sign-In service and basically implement what they've described. So if you do this yourself, there are some things you need to consider. So UX considerations, these are the things I'll go over a little bit more quickly. The first one is about using an authenticated session on this second device. There are some usability considerations. Using an authenticated session on device B is essentially taking advantage of the fact that the person's already signed in on their laptop or their phone, i.e. they're signing in without signing in, because they are already signed in, right? So recall we have two devices, the game console or whatever, and remote signing in means you sign in on B to be signed in on A, right? That's what I mean by remote. If they're not already signed in on B, then they have to sign in. But if they are, they're going to get to a screen that has an avatar and a name because they're already signed in. So on desktop, this isn't mysterious at all. Like, we don't find it unusual that you would go to URL and take advantage of being signed in already. On phones, it takes a little bit more thinking if you haven't really thought it through. Specifically, on mobile, we chose to use the exact same web application as we use on the laptop, but we show it in a web view in our native app. And so when you type in soundcloud.com/activate, that address associated with the app opens up, and the app loads this web view. And the app, the native app tells the web view which user is signed in. And I'll just describe that briefly. So we first open an OAuth 2 style callback address. If you're familiar with OAuth 2, this is essentially the same concept. So it attaches the access token on the URL of this callback. It says this is the user who signed in a query fragment, which is how it's recommended to pass these things on this client side. And it also tells this web app how to display itself. So we're saying you're in a web view, but you could say I'm on my Android phone, make this skin look like my Android app, make it look like my iOS app or whatever. Hide headers and footers, because I have my own headers and footers in the native app. And then it displays. And of course, you could also put this directly in your native app, but what we liked about this is we can quickly iterate our web view without redeploying the native app or without requiring anyone to upgrade to get any kind of new security features. So that's outlined in detail in my blog post. Another thing to consider is easy to read and type codes. So I'll just clarify what I mean by this. You want it to be easy to type this code, right? So the first thing to consider is sparse usage. And for those who aren't native speakers, sparse is not a common word necessarily. It means a small percentage, really spread out. This is a visual representation of sparse. There's some security implications that might be obvious, which I'll cover, but really this is about usability. So it's maybe easier to explain this with a trivial example. So imagine I had just 10 codes, the digits 0 through 9. It would be really unlikely that a person would mistype that one character. They're like 3, they've got it. But you can only issue 10 codes at a time. No one would ever do this, but I hope it proves the point. So you think, okay, like how many characters do I need? Maybe if I had 2 letters, I'd have 676 codes. If it's this long, there's some possibility they might make a typo, and suddenly you need to make sure that you don't accidentally type the similar code to someone else, so you can't issue all the codes at the same time. So you're thinking, okay, well, how many codes do I need? Okay, 6 numbers is 1,000,000. That sounds pretty good. Might be all you need. Maybe 4 letters is good enough. It's like 500,000, not bad. You could mix letters and numbers, but like don't mix letters and numbers that look similar, even if you have a font that makes them clear. But if you did this, you'd have 1 billion codes, which sounds pretty good, which is the number we chose. We chose a mix of 6 letters and numbers for 1 billion codes. Don't use special characters. That's just asking for trouble. I have a side note about Roman characters in countries where they don't use Roman languages, which is we talked to some people and they're so used to this when they're using their consoles that they always have that other Roman keyboard handy. Things to consider: use uppercase for readability, but verify with case insensitivity. We use CSS transforms to always make them display large, regardless of what they type. So now we'll move on to the real meat, which is the security implications. So as I originally described it, there are a number of security problems that you may or may not have noticed, ranging from mild and unlikely to wildly irresponsible. So I'm going to talk about mitigating these security issues by adding some details to the basic implementation. So we'll talk about risks. One risk is you accidentally grant device A access to the wrong user. You know, somebody is signed in, but who? If you're like me, I have a Google personal account and I have a work account, and I'm never signed in as the user I want to access the correct documents and stuff. And if they use your service, they might one person might share one device, maybe they share a tablet, and they need to know who's signed in. So it's pretty easy. In order to mitigate this, of accidentally granting access to the wrong user, show which user is authenticated and allow them to switch. So show the name of who's signed in and the avatar. Or you could display a selection and make them choose. Facebook does A, SoundCloud does A, Google does B, sometimes a mix. So make sure you just tell them who's signed in, who's about to give away their access. Another risk is accidentally granting access to someone else's device. It's best to explain this with an example. So we have one device, let's call it AN, and it's going to show Nina this code, XXN. And then somewhere in another country, there's another device, AM, showing Michael, XXM. If Nina accidentally types XXM and confirms it, she has just given her account access to Michael's device. Michael might not even notice. Like, he's not trying to take over her account. He's just, you know, typing it, and he's like, oh, I'm already signed in. Cool, I'm going to keep going, right? That was totally unintentional on Michael's part. Nina needs to be protected from making this mistake. So how do you accidentally mitigate, or how do you mitigate the risk of accidentally granting access to someone else's device? You have a sparse usage of codes. So if someone accidentally types something very similar to what you told them, there's really unlikely that that's actually a valid code out there. Because if there's two that are so similar, you're not using sparse enough codes. It should be very unlikely that a typo is going to land on another person's code. The other thing you can do is you can collect the device name, and then you can show it during activation. So if the device was called DJ's TV, then I could say, oh yes, I do want to grant this to DJ's TV. This is how like Bluetooth would work. Turns out that on Xbox One, you don't get the device name, so the best we can say is that it's an Xbox. I don't know, maybe we don't have the right level of access. So that's something to consider if that's possible. So another risk is that an attacker just uses up all the possible codes. They just request codes, like they just keep requesting codes and they just use up all the codes. And they're doing this to ruin your reputation or destroy your business, or be a jerk. They're one of those three. And if all your codes are generated on request, whatever is trying to generate a code and check to see that one's available, like that might just slow down to a halt even before you've used up all the codes. So how do you mitigate the risk of an attacker using up all the possible codes so no one can sign in? You rate limit the ability to request codes. And you rate limit this on the IP address or the device ID, you might require that. Whatever features you can get from the request, you would want to limit on those things as a set and separately. And you will need to investigate what is actually a reasonable number of requests kind of at peak so that you don't accidentally block an entire super fun LAN party all in the same IP from like individually accessing things or whatever. SoundCloud has problems where dorms all have the same IP, and then suddenly we think they're all spammers, when really they just want to get access. So another thing you could do to mitigate this is to expire the code. So you give one out, and then once it's used, you expire it so that you can give it out later, and then you can keep your usage down by reusing codes, but don't reuse them too often, because if you reuse them too often, then you end up with this being able to accidentally give access to someone else. So if I take too long to find my device and I finally enter the code in, I don't want to accidentally give it away to somebody who's been reissued that same code. So another risk is an attacker just guessing codes and giving them access. This is a brute force attack, and the person just runs through all possible codes to try and get access tokens that are like runs through looking for confirmed ones. So essentially the attacker is pretending to be device A, and they're just continually asking. And this is the easiest attack to imagine. It's the easiest to implement, but it's very easy to protect against this, actually. The solution is not obvious. It wasn't obvious to me, but luckily I consulted our security team before I built anything. So, quick aside, why would attackers want access to random accounts? Don't have time to cover that. You can ask me later. So, mitigating the risk of an attacker guessing codes to get access tokens. You could use very, very sparse code usage. Make it really hard to guess. Unfortunately, that requires really long codes, which is the exact opposite of what I said you wanted for usability. You want shorter codes. This is basically how access tokens work. They're just long and hard to guess. The whole point is you want something easy to read, so this is not a great solution. You could rate limit for polling, so you can only poll so frequently. You should still do that, but it doesn't really help you too much. The trick is to add a polling token. You just issue a very long and hard to guess token with the other token, with the short token, and you must provide the very long token in order to ask questions about or exchange that other token. So You issue that, you issue the polling token with the very easy to read token, and you require it when you're checking the status or when you're exchanging the code for an access token. And this is outlined in detail in Google's implementation. They call it user code and device code. So don't worry, Google thought of that. Another risk is people tricking you into giving away access to your account. I don't have a lot of time to fully explain this, but this is basically a social engineering attack where they take advantage of the fact that DJ's TV is a string, and if you replace it with something like SoundCloud Premium add-on, it looks like you could send this link to someone and say, confirm that you want to have a SoundCloud Premium add-on. And then the person's like, I do want that. And they've just given away access to their account. And this can be a personal attack or a random attack. The way you mitigate this is you make sure that the UI, the text, and the design elements make it very clear what's happening. And I think there's this idea in design that we need to just remove all the UI and make it self-explanatory. But these kinds of social engineering attacks become very easy when there's no context for what the text is supposed to be. So here we say, confirm your device. Sign in on this device, the device name. Yes, activate the device. By activating this, you are giving away access. Like, make it really clear what the consequences are. For a security purpose, this text is necessary. From a design perspective, your designers might think this is too cluttered, but from a security perspective, you need it there. You could go further and say, hey, you're at a different IP address than I confirmed the code at. Are you sure? And this is another way to protect against that. The other one is to have really short expirations. So if the code only lasts for 2 minutes, it would be very difficult for a person to craft one of these attacks because the person would have to act within 2 minutes. And if it expires in a very, very short time frame, they don't get the opportunity to act quickly. So all of this is covered in my blog post, so I'll just give you some closing thoughts. That was a lot of material, but it's all written down. So my closing thoughts are that, yeah, using a game controller to enter a password is not fun. I imagine trying to like scroll a keyboard on your watch would even be worse. But designing and implementing a new kind of authentication flow is fun, surprisingly fun. And our team really enjoyed it. We really liked thinking through this problem. But definitely involve your security experts really early on. We involved the security experts. We were like, we're thinking of doing something like YouTube. And they came to us with basically an implementation. They had completely understood and thought out all these problems, and we just had to build it. So we went from this really painful experience of like navigating around to something that felt so magical that people were excited to use the SoundCloud app on Xbox because this magic sign-in happened. So yeah. Try it out, and thank you.